Let us explore more about heat by entering part 3. All the coefficients for linear expansion, area expansion and volume expansion have the same unit, which is per Kelvin or per degree Celsius. And for area expansion, involving the expansion of a surface area of an object. Consider a plate with initial area A0 at temperature T0 is heated to a new uniform temperature T and expands by change of area. Consider a square plate with side length L0 is heated and expands uniformly. Everyone knows that change of length equals to alpha times L0 times change in temperature. When you expand it, you will get this equation. So when you square the whole thing, you will get the equation in a quadratic form. So you expand this mathematically till this stage. For the small value of coefficient of linear expansion, here, when you square this, this part, the value is approximate to 0. So this portion become invalid. So we can cancel out this. The final equation only on this range. So now the change of area equals to 2 alpha times A0 times change in temperature. We assume 2 alpha is equals to beta, and the beta will be coefficient of area expansion. Once we know beta is a coefficient of area expansion, it gives you a new formula, which is change of area equals to beta times the original area times the change in temperature. Simple like a bubble without giving you any trouble. But for your syllabus, you only have to know this formula. The whole mathematical process to get these not in the PSPM syllabus. So in the PSPM syllabus, we just have to understand and use this formula. How to derive not in the syllabus of PSPM. The cheapest pay in the world is pay attention. So please take note about what I mentioned just now. So now state the relationship between coefficient of area expansion and linear expansion. Everyone knows that beta coefficient of area expansion equals to 2 alpha. Alpha is coefficient of linear expansion. So beta equals to 2 alpha. So beta equals to 2 alpha. Simple like a bubble without giving you any trouble. This type of questions quite famous in PSPM. And now let us see volume expansion. And again, all the mathematical process is not longer in PSPM syllabus. And it is crystal clear when you square this part, the value is approximate to 0, and same thing goes to this part, will give you the value which is approximately 0. So the equation only on this range from here to here, where L cube is V, L0 cube is V0, L0 square times L0 will give you L0 cube, which is V0. and will be in this form. So V minus V naught, which is equals to 3 alpha times V naught times change in temperature. V minus V naught is change in volume, and we can assume that 3 alpha is equals to gamma, and gamma is coefficient of volume expansion. So the equation turns to be in this form, where change of volume equals to gamma times V naught times change in temperature. Let us state the relationship between coefficient of volume expansion and linear expansion. So the answer is gamma equals to 3 alpha. Define coefficient of area expansion by using the formula of change of area equals to beta times A naught times change in temperature. Beta, so-called coefficient of area expansion, is equals to change in area per unit area or original area per unit rise in temperature or change in temperature. Or you can define all the symbols, where beta equals to coefficient of area expansion, del A is change in area, final area minus original area or initial area, A naught is original area, del T is change in temperature, where final temperature minus initial temperature or original temperature. Or beta is defined as the change in area per unit rise in temperature. The unit is per degree Celsius or per Kelvin. And how about this? Define coefficient of volume expansion by using the formula of change of volume equals to gamma times V naught times change in temperature. So the coefficient of volume expansion is equals to change in volume per unit volume or original volume per unit rise in temperature or change in temperature. Or you can define all the symbols, where gamma is coefficient of volume expansion, del V is change in volume, final volume minus original or initial volume, V naught is original volume, del T is change in temperature or final temperature minus original or initial temperature. Again, gamma is defined as the change in volume per unit rise in temperature. The unit for coefficient volume expansion is per degree Celsius or per Kelvin. So all the coefficients have the same unit. Simple like a bubble without giving you any trouble. Thank you for watching this video. Thanks a lot, and thank you to the Lord.